Good morning, students. In this video, explain about the remaining portion of dynamic programming algorithm. Already explained about the concept of dynamic programming algorithm. So that means here to specify the 4 steps are there. First one is optimal substructure. Second one is optimal solution. Then after compute bottom-up approach to solve the optimal solution. After then conclude the optimal solution. So these are the main concept of dynamic programming algorithm. So already explained about that. Okay, what is the principle following the dynamic programming? To follow the optimality, because dynamic programming to following optimality concept. Okay, can you get this concept? First to find problems, break up into a lot of problems, then after to find the more than one solution, then after to conclude the feasible solution, then next after to apply the criteria, then to find out the optimal solution, then after to compute the optimal solution, that means it is following the bottom up approach, then to conclude the optimal solution. Okay, so that is a concept of to solve the dynamic program. Then after, so in this video, the main concept of in this video to explain about the example program or example problem to following dynamic programming. Okay, so in dynamic programming, to solve the problem, to following two methods are there. One is memorization method. Memorization method. Then second one is tabulation method. Okay, two tabulation. So these two methods are used to solve the problem in dynamic programming. Okay, so here we can take the example Fibonacci series. Okay, you are already know about this concept, Fibonacci series. Actually, what is that? Then first number is 0, then second number is 1. Then you can assign these two values of two variables. Then how can get the third value? That means add two previous two numbers. Then next value, that means 1 plus 1 equal to 2, 2 plus 1 equal 3, 3 plus 2 equal 5, 5 plus 3 equal 8, 8 plus 5 equal 13, and so on. Okay, then how can define the term of Fibonacci series? 0th term, then first term, second term, third term, fourth term, fifth term, sixth term, seventh term, and goes on. Okay, so these are the Fibonacci series. Then how can define the Fibonacci series? Then definition, that means if n equals 0, it must be written 0. Then if n equal 1, it must written 1. Suppose n is greater than 1, then to do this function, that means n minus 2 plus n minus 1. If you have the nth term of Fibonacci series greater than 1, you must to do the function fifth of n minus 2 plus fifth of n minus 1. Then after you can get the answer, then add it to these two function calls, then you get the answer. So that is the definition. The next, how can write the algorithm of Fibonacci series? That means ind. So use the function definition ind fifth of ind n. That means to find the nth term of Fibonacci series. Okay, then after to check the function, that means n is less than or equal to 1. That means the nth value, if it is less than or equal to 1, it must return n. So already explained, n equals 0, n equal 1. So that is less than or equal to 1, you must return that value. Sometimes the nth value is greater than 1, then to do this function call. So this is the algorithm. Okay, just you can understand this concept about the Fibonacci series. Okay, then after to trace the tree to find the fifth term of Fibonacci series. Okay, so we can find fifth term of Fibonacci series. Okay, so the diagram is tracing tree. Okay, tracing tree. Okay, the next 5 is the nth term. Okay, so the 5 values enter into this function. N is less than or equal to 1, so that is not satisfied because n is biggest than 1. So to do this function called n minus 2, that means 5 minus 2, 3, fifth of 3, then 5 minus 1, fifth of 4. Then 3 is less than or equal to 1, so that is not satisfied. Then again to do this function, 3 minus 2, 1, 3 minus 1, 2. Then again 1, fifth of 1 is enter into this condition. Then if it is true, that means it return n. So here 1 is the answer. So this value is stored from this function. The next fif of 2. Fif of 2 is enter into this condition, then 2 minus 2 equals 0. Then next 2 minus 1 equal 1. So fif of 0 and fif of 1. So fif of 0 then enter into this condition. So the condition is true, then the value is written n. That means 0 is written here. Then fif of 1 already here, find the solution. Okay, the next fif of 4. Fif of 4. 4 is enter into this condition. N is less than or equal to 1. That means 4 is less than or equal to 1. So that is not satisfied. So to do this function, n minus, then with 4 minus 2, 2, then 4 minus 1, 3. Then again 2 is less than or equal to 1. So that is not satisfied. The 2 minus 2 equals 0. Fif of 0 you can get. Then 2 minus 1, fif of 1. Okay, then next, so it must return the value 0, then fif of 1, because 0 is less than or equal to 1. So here is 0, then here is 1. So that is 1 is written here. Okay, then fif of 3. 3 is enter into this condition. 3 is less than or equal to 1. So that is not satisfied. Then 2 to this function, n minus 2. So 3 minus 2, 1, 3 minus 2, 3 minus 2, 1, then 3 minus, okay, 1, 3 minus 1, 3 minus 2, 1, 3 minus 2, 1, 3 minus 1, 2. Okay, then again fif of 2. 2 is not satisfied. So 2 minus 2, 0, 2 minus 1, 1. Okay, so this is a function calls. That means fif of is a function call. Fif of is a function call. So the functions calls are a repeat again and again. Okay, so we want to find the fifth term of Fibonacci series. Then how many times the function calls are repeat again and again. Okay, so many times. That means here the same function call. Okay, fif of 1, 1, 2, 3, 4, 5. Okay, 5 times the same function call and same parameters repeat again and again. At the same time, fif of 2 is also a next function call. So this function call is repeated again and again. Okay, so the same function calls are repeated again and again. So it can take lot of time. So the time complexity is high. So the main program or master theorem is defined as T of n equal to n 2t n minus 1 plus 1. So that is big O of 2 raised to n. Okay, big O of 2 raised to n. So that is the time complexity. So here is not 2n, 2 raised to n. Okay, some printing mistake. So you can correct it. So what is the time complexity of the repeated function call? To use big O of 2 raised to n. Otherwise big theta, theta 2 raised to n. So that is a time complexity. So it can take lot of time. So how can reduce this function called repeat again and again? So this is a recursive concept. The same function called repeat again and again. So we must reduce this function calls. Okay. Then only we can calculate the problem. Okay, so these are the additional feasible solutions. So many feasible solutions are there. So we can conclude the optimal solution. So we must reduce the function calls. Then only we can get the optimal solution. Okay, the next diagram explain about this. The same trace tree is also given here. Then I can write only what is the reduced value. You can get this. Okay, fif 1 is written to 1 is the answer. Then fif 0 written 0. Okay, then here, then after how can get the previous value? That means 1 plus 0. You can 1 plus 0. You can get the answer 1. So fif 2. That means the fif 1 is already returned the value 1 and it is stored from there. Okay, so fif 1 is store their value. What is the value? 1. Okay, then fif 1, then fif 0 is also get the value. So that answer is storing from there. Okay, then after how can calculate the fif of 2? Then 1 plus 0, then you can get the answer 1. So fif of 2 is get the value 1 is the value. Okay, then after fif of 1 is already calculate the value. So this function is not repeated again. Actually, what is the value is there? 1 is the value. So here take the value 1. So 1 plus 1. 1 plus 1, 2. So fifth of 3 is 2. Okay, then next go to fifth of 4. Okay, fifth of 4 is not calculated. Okay, so then here fifth of 1, fifth of 0. Okay, fifth of 1, fifth of 0. Then all functions fifth of 1 is repeated. Okay, complete. Then fifth of 0 is also okay. We can't repeat again this because we don't repeat the same call again and again because we are already find the value. So what is the value of fifth of 2? Already we are calculated from here. So what is the value is there? 1. Okay, then so this is also not calculated. Then fifth of 3 is already find it. So this is not calculated. Just you pick up that answer. So 2 plus 1, 3. So that is the answer of fifth of 4. Okay, so in the previous tree, so here how many function calls are repeated here? Then 15 function calls are here. 15 calls. Okay, just you calculate 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 function calls are there. So, but in this structure, so we can reduce the function calls repeat again and again. So this is a memorization method. Okay, so now I'm here take just an array is here given here. This is an array given here. So first to initialize the array's values are -1 in all columns. -1, -1, -1, -1. Okay, then first we find the fifth term. Okay, what is the value is assigned there. Okay, so -1, just to imagine -1 is there. Just to imagine, just to put the minus values from that array. Okay, so first to fifth term we don't know about that value, so we can't calculate that. Okay, then after third term is also we can't identify that. Then first fifth of 1, but we can return the value 1. So minus is cut it and after 1 is given here. Okay, then fifth 0, the value is also, then this is -1 is cut it there. Then because 0 is find here, then 0 is we are writing here. 0 is writing here. Okay, then first two values we can get here. Then after the next fifth of 2. Fifth of 2 is also now 0 plus 1. Now we can get the answer. So cut it there. Then 0 plus 1 equal 1 is right here. Okay. The next is fifth of 3. Then here is 1 plus 1, 2. Get so fifth of 3 is cut it here. That 1 plus 1, 2 is given here. Okay. Then next is fifth of 4. Fifth of 4, 2 plus 1, 3. So we can get 3 is given here. Then last fifth value. Then 2 plus 3. 2 plus 3. 2 plus 3, then 5. So this is the memorization method. So what is the main concept of memorization method? Memorization method means to avoid the repeated function. Avoid the repeated function. Then suppose we have find the value from the function called only once and you can get the result. That result is storing from there. That means a function call can use only once. Don't repeat again and again. So that is the memorization method. Okay, can you understand this concept? I think you can understand this concept. So in memorization method, that means what is the main concept? I am repeat again. The memorization concept means the function call can active only once. Then after you can get the result. That result is storing from there. If any function call is repeated in that structure, then you can avoid that function call because you are already calculate that value. So you pick the value from there and then after to compute the task. Okay, so the first this is a memorization method can approach top down technique because first to trace the tree, then after to avoid the function calls, then return back, then 0 plus 1 1, then 1 plus 1 2, 2 plus 3 5, then return back to the answer. So this is a top down approach. Okay, top down approach. So the memorization method is also top down approach. So the tree is generated and the function calls are avoided and the result is obtained back, started from top to bottom. So this is a top down approach. So memorization method is a top down approach. So here the first tree is 15 calls are there. So then after to reduce the function calls, then how many function calls are there? 1, then 2, then 3, then 4, this is 4, then 5, then 6. Okay, then fifth of 1, then fifth of 3 2, then fifth of 2 3, then fifth of 1 4, then fifth of 0 5, then fifth of 4 6. Okay, so only 6 function calls are needed to solve the problem. Okay, so the time complexity is now reduced. That means 2 raised to n. So before we calculate the problem, we go of 2 raised to n. So that 2 raised to n exponentiation terms reduce it to nth term. So that is linear. That means exponentiation to polymer. Then fifth of n. That means how can calculate the nth term of Fibonacci series? Then fifth of n equal n plus 1 calls. That calls are enough to to find the solution of dynamic programming using memorization method. Then after we can get the final answer is big O of n or theta of n. Okay, only need the n values. Okay, n values, that means n solutions. N solution enough to solve the problem. Okay, I think you can understand this concept. Okay, it's a very simple concept. Then suppose you can't get any idea from this diagram because the limitation is there, and we have no board, only the PPT is the only source to solve the problem. I think you can understand. Otherwise you can ask through our group. Okay, or Google Meet. Okay, thank you.